right about now. Good morning, everybody. Hopefully, you all are having a thankful Thursday. The time now is 4 minutes after 11 in the morning, and we are not going to prolong this any longer. We're going to go ahead and get started. I'd like to say thank you to Mr. McFadden for joining me this morning. Really do appreciate your support and your consistency because that's what's important to me, consistency. All right. So, anywho, we are continuing on with our topic of like terms and monomials and binomials and all them other nomials that we talked about yesterday. If you don't know what the heck I'm talking about, please go ahead and watch the playback videos from Tuesday and Wednesday because this is all coming together for this particular session. All right. So, what I want to do is I want to go over these problems that I assigned to the students on yesterday. So I just wanted to go ahead and go over these and just making sure that they understand how combining like terms work and all that good stuff. I heard another ding, so I just wanted to acknowledge the ding that I heard. Good morning.
My name is Hampton.
Good morning, Miss Philomena. Thank you so much for joining us. We just started recording, so you came, right on time.
Okay, thank you.
Yes, ma'am. So if y'all could go ahead and just put your mics on mute for a quick second. I'm just going to do a recap of what all we've done for this week. So basically, all this week we have been discussing like terms and unlike terms, how to add them, subtract them, multiply them, and divide them. Some of them you can't add them or subtract them because they're unlike terms, and for some, you can multiply like unlike terms and divide unlike terms. But remember, if you missed any of that, please, I encourage you, strongly advise you to watch the playback video, especially the playback video on Tuesday, because the playback video gives an overview and a breakdown of everything that we have covered thus far as it relates to like terms, unlike terms, and polynomials. Okay. So, with all of that being said, we are going to go ahead and go over this worksheet. Now, um, excuse me. Now, remember, it's very important that you remember the rules because different rules do different things. Okay. So, the techniques and strategies that I'll be giving to you today is simply this. You have to ask yourself when you're looking at an expression, is it like terms or unlike terms? So that's the first question you ask yourself. Do they look like they're identical twins or do they look fraternal? Okay. The second question is once you determine whether they are like terms or unlike terms, then you can determine whether or not you can add, subtract, multiply, and divide if they are like terms. If they are not like terms, you cannot add or subtract unlike terms. Okay. So remember, unlike terms are fraternal twins. They have letters, but they're different letters. So you can't do anything with those. Okay. Now you can multiply and divide unlike terms, and we'll be doing some more practice problems with those momentarily. And I also want to get into today multiplying monomials with binomials and all them other nomials. So let's go ahead and get started. All right. So for number one, and all right, there we go. A little floating to a bar here. All right, so for number one, we have 2D minus 5D. So you have to ask yourself, are these like terms or unlike terms? And y'all can take yourselves off of mute to answer the question.
They are like terms.
Yes, sir. They are like terms. They are like terms because they both have a D. All right. So now you have to ask yourself, can I subtract like terms? And of course, we know the answer is yes, we can subtract like terms. So what is 2 minus 5?
Negative 3D.
Yep, my answer is negative 3D. Ooh, that looks ugly, but I'm pretty sure y'all will take that. Y'all take that. All right, so I'm going to put over here like terms. Okay. I'm just going to put like or unlike. It's just too much writing. All right. So now I'm going to scroll down to number 2. Okay. Now, again, you have to ask yourself, do you see any like terms in number 2?
Yes.
Okay. And where are they, Miss Philomena?
5p plus 6p.
Yes. So these are my like terms. Okay. So 5 plus 6 gives me what?
11p.
11p. All right. Now I have to bring down this 7 because that was a part of it. But my question is that my final answer?
Yes.
Yes, it is, because 11p plus 7, this is an unlike term, so I cannot add unlike terms. Okay. So because this is unlike terms, that's my final answer. I cannot do anything else with those. Okay. So I'm going to go ahead and just go in alphabetical order, numerical order. So we'll come back up at the top, numbers 6 through 10. All right. So for number 3, again, do we have any like terms?
Yes.
Okay. And what are they?
The 4 and the 9.
4 and 9.
Yep, the 4 and the 9. So what I like to do is, and again, you do not have to do this, but if it helps you to do this, please do so. I like to put all of my like terms together simply because that will let me know what it is that I can do and what I can't do. Okay. So now that I've combined my like terms, I know that 4 plus 9 gives me what, 13?
Yes.
Yeah.
Okay. And that's going to be minus 8m. All right. So is that my final answer?
Yes.
All right. Excellent job. And remember, I'm just only putting that as unlike to let anyone that's watching the playback know that I cannot add or subtract unlike terms. Okay. How we feel so far with the first 3? We feel okay?
Mm-hmm.
All right. That's what I like to hear. All right. So number 4. Now, number 4, I'm going to switch over for a quick second. Number 4 is something that I actually want to talk about today.
Excuse me, Miss Hampton.
Yes, ma'am.
Does the answer really matter in the position of the answers?
So do you have negative 8m plus 13?
Can the negative 8 come before
Okay, so
13? Can it be reversible? And the answer will be correct. Yeah.
Okay, so that's what I was asking. Did you write this?
Yeah.
Yes, ma'am. This is actually the correct way to write it if we can be technical about it.
Okay.
But either way is okay for right now. But you want to get in the habit of writing your expressions with your letters first.
Okay.
If that makes sense. So either way is fine. Well, that was a good question. And I'll explain why it is important for you to write your letter first, or your term with the letter first, and then the number by itself. When we get into those quadratic expressions and quadratic equations, that's really where it's going to all make sense. So I just want to encourage you all, as always, get into the habit of doing things a certain way, because when we are introduced to new concepts and you see these things again, you'll be like, oh, okay, I understand why we had to do it. All right. All right, but great question, Miss Philomena. All right. So number 4, I want to talk about number 4 really, really quickly because number 4 actually has a lot to do with our lesson for today. Let me see if I can type it. And I'm going to, of course, make that. Come on now. All right. So distributive property. I'm going to make that a little smaller. That way y'all can, hopefully y'all can see it. All right. So what does the word distributive mean? And if you don't know, just say, Miss Hampton, I don't know what the word distribute means. I mean, it's okay. All right, there we go. I'll put that up there.
To dish out, to distribute.
Yeah, to give.
Yeah.
So so remember to distribute something means to give. So what we're going to do, we are going to give this 8 number that's outside of the parentheses. And remember, anything dealing with parentheses, that is automatically multiplication. That's very important for you to remember that because they do not have the multiplication sign in algebra. They use parentheses to denote multiplication. So what we're going to do is we're going to give this 8 to the 4th multiplication, and we're going to give this 8, this 9m through multiplication. Okay? So when I do this, what is my answer? I'm going to go ahead and just type it.
32 plus 72m.
And we got 32.
Yeah.
Plus
72.
M.
Okay, plus 72m. And then we have, what is that, minus 6?
Minus 6.
All right. All right. Excellent job. Now, again, this just only reinforces multiplying like terms. So here, all right, so here we multiplied our like terms, which were the numbers, and then we multiplied unlike terms, which is the number and the term. Okay, so this is just reinforcing to remind you that you can multiply both unlike terms and like terms. Now, my next thing is, do I have any other like terms that are in this particular situation?
Yes, right, ma'am.
Okay. What are they?
The numbers 32 and 6.
All right. So I'm going to say 32 minus 6. So remember, I'm putting all my like terms together. I'm going to add that 70. I'm going to say plus 72. And when I do this, that's going to leave me with what? 26? Yeah, 26.
26.
Plus 72.
72m.
Now remember, I'm going to do some spacing. You can also write your answer this way, which is actually, again, rated.
That's your final answer, right?
Yep, yes. That's my final answer. It sure is. So I'm going to go ahead and make this. Oh, come on now. Uh-oh. All right, there we go. And now I'll write unlike terms. That is my final answer. Can't do anything else with that. All right. All right. So now we are down to the bottom of this first column here. So, so I want you to tell me what you did for number 5. If you did anything to number 5.
You multiply 8 times 4.
Okay. Yep. Okay. Why is this thing acting so? All right. All right. So yes, that's exactly what I did. So you're going to come across problems like this. And a lot of people, they say, well, Miss Hampton, I don't know. Should I multiply the 6p to the, no. What you want to do is you want to multiply the number or the term that is closest to the parentheses. Okay, so in this instance, our number is -4. And also remember the number takes a sign. Okay, so when I do that, I'm going to multiply those two together, and then I'm going to multiply the -4 times the 2p. Okay, let me go back over here. And when I do that, all right, I'm going to go ahead and write out 6p. Okay. Y'all can see it. All right, so what is -4 times -8?
-32.
-34, +32.
+32.
Yep, because remember, a negative
Negative
times a
times a
negative
negative
gives you a
is a
positive.
positive. Yeah.
Right, so that's going to give me +32. Now, when I multiply this -4 times this +2p, that's going to give me a what?
-2.
No, not -2. Remember, Miss Philomena, we're multiplying. -4 times a
Negative,
+2.
-8.
-8. All right. Oh, not 9, Miss Hampton, it's 8. All right. So when I do my distributive property, my negative times my negative gives me this +32. And then my negative times this positive 2p gives me a -8p. So we are really reinforcing those integers. Remember, integers are just positive and negative numbers. Can't get away from it. You just can't. Algebra is nothing but integers, okay? So with that being said, what I want to do now is I want to move this down here. Do I have any like terms?
The 6p and the 8p.
Yep. And let me see if I can really. Ooh, okay. Yeah. Try to highlight them guys. Okay. All right. So I have a 6p and I have the 8p. So I have 6p minus 8p plus 32. And when I do that, 6 minus 8 gives me what?
-2p.
Negative, yep, that's it. -2p. Then I have to bring my 32 down. And is that
And
my
that's your,
final answer?
yeah, that's your final answer.
Why is that?
Because you don't have any like terms to add or subtract by.
Exactly. All right. So okay, so remember, I'm just again for the people that's watching the playback, I'm just letting you know that you cannot add or subtract unlike terms. So don't try to say that that's 30p, or don't try to say, 32p and carry it to like you can't make up rules when it comes to these things. All right. So it's very important that you make sure that you know all the rules and where they are applied, if that makes sense. How do we feel so far about the first half? Do we feel good?
Yes.
Okay. What about you, Miss Philomena? You feeling okay?
Yes.
Okay. All right. Y'all are doing a great job, by the way. So let's keep this momentum going. And that's supposed to be me highlighting that clearly it didn't work. All right. So now we're going to scroll over to number 6 through 10. All right, make sure I got enough room. All right. So now I want you to tell me what I got to do here.
You got to multiply the like terms.
I think I heard both of y'all say it. You said, Mr. McFadden, to multiply, and Miss Philomena, you said distributive property.
Yes.
Yep, both of you all are correct. So give yourselves an air high five. Even though you can't see each other, I'm just saying. All right. So again, to anybody that's watching the playback, this is just step-by-step directions on how to do this. I'm going to also go ahead and all right. I'm going to say distributive property. All right. So when I do that, tell me what I'm going to have.
Negative 45y.
Okay, negative 45y. All right.
And minus 18.
Minus 18.
Yep. Both of you all are correct. Negative 45y minus 18. That's it. That's my answer. Okay. All right. Y'all are doing real good with these. Which I knew y'all would. I knew you all would do wonderful with these. So I'm not really worried. All right. Matter of fact, come on now. All right. So that way, I'll just do that. All right. So I have number 7. Number 7 is the same thing as number 6, right?
Distributive property.
Ma'am?
Distributive property, multiplication.
Yes, absolutely. So I'm going to do that. And I'm going to do that. And when I do that, let me see. Let me do a copy. Okay, so we're just using distributive property, but I'm going to change these bottom numbers here. So what is my answer when I do my distributive property?
Negative 45x minus 40.
Okay. 45. So 45s. All right. So what I'll do is I'm going to go ahead and rewrite it. So that way, but if you wrote it out this way, that's okay. All right. But either way, so I have negative 45s minus 40. Not 30. It's Hampton. 40. All right. All right. So again, we are using distributive property. All right. So let's look at number 8. The good news is with number 8, we do not have distributive property here, but we do have some like terms that are going around. So tell me what my like terms are for number 8.
The 9 and the 6.
Okay, I have the 9 and the 6.
And the 4y.
4y.
And the 5y.
Yep. Let me make sure I have enough room here. All right. Let me move this out the way so y'all can see. All right. So we have 9 plus 6. Well, actually, this is what I'm going to do. I'm going to put my variables first. I'm going to say 4y minus 5y. Remember, always know that the number takes a sign. And then I'm going to say plus 6 plus 9. All right. And when I do this, tell me what my final answer is going to be. Uh-oh. Let me,
okay, negative y plus 15.
Yes, ma'am. Negative y plus 15. That's it.
Negative 5 minus negative 5y minus negative 4y will give you negative y. Instead of 1, it becomes y.
Right.
Yeah.
All right. Mina, you are on it today. Whoop, whoop, whoop. All right. Well, both of y'all are on it today. You really are. All right. So that is my final answer. And of course, I know that this is unlike terms because I cannot add a negative letter or any letter to a number. I cannot do it. All right. We are breezing through these things. All right. All right. Well, number 9 is the same thing as number, I'm sorry, number 9 is the same thing as number 8. So tell me what my like terms are.
7W and the 3W.
All right. And then what else?
-6, -2.
Yes, ma'am. Ooh, y'all are on fire. All right. So now I'm going to type all of this stuff in, which probably should have been. All right, there we go. All right. All right. So now I have 7W plus 3W minus, oops, minus 6 minus 2. All right. So tell me what my answer is.
-10W
And W.
-8. 10W -8.
Excellent job. 10W minus 8. Now, for anybody that is watching the playback and you're wondering how in the world did we get this -8? Let me go ahead and put unlike over. You can't do anything else with them. Okay, so
6 plus 2.
huh?
6 plus 2. Right.
Well,
No,
-6 plus -2. Remember, we have to use that keep change rule. Okay. So what I'm going to do is I'm going to write this out to the side so that way, people that are watching the playback can see this. See, I'm too nice. That's my problem. -6 minus 2. I'm going to use keep change or keep change opposite, whichever you learned it. It doesn't matter. So we're going to keep a -6 the same. We're going to change the subtraction to addition because they are inverse operations. And we are going to change the second number to the opposite. The opposite of 2 is -2. And you see how I put my second number in parentheses. So when I do that, my answer is -8. Oh, yeah. All right. So how we feel so far? This was too easy? I guess not. Y'all not saying. So that means I have to give you all some challenging stuff. All right. And last, what is this thing? What is? Now stop. All right. And last but not least, what is that? What is 6 plus 1?
7.
7. So this is like terms because I have an S here and an S here. Remember, the variable that stands alone has a coefficient of 1. So 6 plus 1 is 7.
7.
That's my final answer. Now I'm going to put underneath that like terms. Okay, you know what? This thing want to act silly. Okay. All right. All right. So are there any questions over this practice sheet? I have to take it as no news is good news. Mm-hmm. Now, of course, if you want another practice sheet like this, please let me know, and you know that I'll be more than happy to send it to you all, and with the answer sheet as well. So if you would like another sheet like this just for more practice, please let me know.
Yes.
Yes, ma'am. Yes,
Yes.
ma'am.
Okay. Well, you know, I got you. I'm gonna take care of y'all because y'all taking care of me, and I appreciate it.
Mhm.
All right. So here's my cursor. All right. So now what I want to do. Is this it? All right. Now I want to talk about these multiplying monomials with binomials. The good news is y'all already did that. So that's the good news. You did it and you didn't even realize you were doing it because this deals with the distributive property. Okay, so I have the example here 3 times x plus 6. And in a lot of the problems that you previously just did and the ones we just went over, they follow this same format. They'll have a number or a term, and you use multiplication for both. Okay, so that's the good news. Y'all already did that. So kudos to you. All right. And I wrote another example here where we have -6 times a minus 7. And let me go ahead and say this. Please do not confuse this with please excuse my dear Aunt Sally, just in case anybody was wondering. I know we have the parentheses, exponents, multiplication, division, addition, and subtraction, but this is not what this is right here. I just wanted to put that out there. Okay. So if you have any questions about that and you're watching this playback, please leave your questions in the comment section and I'll be more than happy to further explain. All right. But this is the bad boy that I wanted to get into today. Multiplying binomials. Now, I know what y'all thinking. What in the world is a binomial? Well, just in case you forgot, where in the world is this it? Here we go. So I just want to come back up here very quickly to show you all what a binomial is. Okay. So a binomial is when you have two monomials together and they are separated by a operational sign. More than likely, it will be either an addition sign or a subtraction sign. Okay. So it will. So when we say multiplying binomials, we are looking at this type of example. Okay. So I just wanted to give you all an opportunity to make sure that you reread over different types of nomials and how they are going to play a very important part in the next couple of weeks of us talking about quadratic expressions, quadratic equations, factoring, trinomials. All of those things go together. All right. So let me know when I can go back to the previous slide, y'all. I guess I can. They did not say anything. I guess I can. All right. All right. So when you are learning how to multiply binomials, there are 3 methods that you can use. And I'm going to go over each method with you all today. All right. The first method is the FOIL method. This is the method that is very common amongst the algebra mathematics community. Okay. That deals with first, outer, inner, last, and that just simply reinforces multiplying like terms and unlike terms. Okay. The second version or the second method is the box method. So the box method, if you are a visual person and you like to draw pictures or whatnot, you're just going to draw a box. It's going to look like a window and you're just going to put certain things where they go. But I'll break that down further momentarily. And the distributive property. So the distributive property is when you're going to break down a set of binomials into monomials and you will multiply them by the second binomial. But don't worry, I'm going to explain. You're going to see all of that in a minute. I want to give you a brief overview. All right. So this first method is the FOIL method. Now, again, in my Tuesday video, I did a clear breakdown of how all of these things work. Okay, so I strongly encourage you to please watch that video because I'm showing you step-by-step directions on how to solve binomials by using the FOIL method. Okay, so, all right. So what we have here, we have x plus 5, and that's in parentheses. So that's one binomial, and that's multiplied by x minus 7. That is the second binomial, okay? So what I've done is I have broken down what each letter stands for, and I have also written out what you are actually multiplying, okay? So F is the first term. So you are just simply multiplying terms in different ways, okay? So X is my first term for this binomial, and X is my first term for the second binomial. So I am multiplying X times X, and that gives me X squared. Remember, these are like terms. So because they are like terms, I am going to multiply my numbers, which is 1 times 1, but I'm going to add my exponent. So again, if it helps you to write a 1 at the top to remind you that you have an exponent there, do it. And 1 plus 1 is 2. So that is how we got the x squared. All right. The O stands for outer. And you see I've used different colors to represent, you know, what's being multiplied. All right. So according to the O stands for outer, and I am going to multiply the outer terms that are on the outskirts of the parentheses. So here I have X because it's closer to this outer parenthesis. And then I have -7 because it's on the outer part of this parenthesis. So when I multiply -7 times X, that gives me -7X. So far, I have multiplied like terms for first and unlike terms for outer. Does that make sense so far?
Yes, Mom.
Okay. All right, Mr. McFadden, you still with me?
Yes, ma'am.
All right. All right. So next we have the I. I is for inner. So of course, by deductive reasoning and common sense, if we know that these two are the outer terms and numbers, then these two would be the inner. So because they're on the inskirts of the parentheses. So we have 5 times X, which gives us 5X. So again, these are unlike terms that we are multiplying. Okay. And then in the green, last, and it is last for real, the L is for last, and I am multiplying the last terms in the binomial. So I have a 5, which is my last term for this binomial, times -7. Okay, so I have a positive times a negative that gives me a negative. Okay, so now I have all of these things over here. I have x squared, -7x, a positive 5x, and a -35. What you want to do is make sure that you are writing these things in order. So that's going back to the previous exercise that we did. It's very important that you write your expression in order, meaning you are going to start with the highest exponent. So we have a 2 here. So our x squared is going to be the first thing that we write. Then we have -7x plus 5x minus 35. Okay, so that's the reason why it's important for you to write your expressions with the letters first, because if not, it's going to look real funny. All right, so we have combined our like terms, which is -7 plus 5, and that gives me a -2. So my final answer would be x squared minus 2x minus 35. So I'm going to go ahead and type this here. Okay. Which will all right. I don't know why this thing always does this. All right. All right. So the FOIL method reinforces multiplying like terms and unlike terms. Also make sure you combine your like terms, which will more than likely be in the middle. So after you write all of this out, you're going to see that your like terms are going, more than likely, they're going to be in the middle. It's very rare that the like terms are all over the place unless the binomials are set up in a certain way to where they will be all over the place. But that's a very rare situation and circumstance of when that happens. But just know that your like terms will always be in the middle and you're just doing what it tells you to do. You're either going to subtract or add. That's it. Okay. Let me know when I can go to the next slide. I have about 14 minutes left. Okay, so is it okay if I move to the next slide, y'all? Well, I guess I can. Y'all not saying nothing, so I have no choice. All right, let me see. Let me scroll. Oh, wow. Look at these things I got. Okay. All right. So the next method that I want to show you is called the box method. And it's exactly what it says it is. It's a box, and you are going to solve these binomials by using the box method. Now, again, to be 100% honest, I remember learning this method when I was in school, but I honestly didn't like it, I guess, at the time. I don't know why I didn't like it, but it took one of my former students to reintroduce me to this method, and now I'm in love with it. So I guess that's just kind of how it goes, right? So this is what you would do. You would simply just break down each binomial into the monomial. So you're going from 2 to 1. And each corner represents where you're going to place your letter or your variable and or your number. So for example, I put x plus 5 at the top, but I want you to see how I broke down my x and I put it here and I put my 5 here. And I put the addition sign with it because remember, the number takes the sign. So the next thing I did the same thing with x minus 7. I put my x over here to the left, and I put my -7 at the bottom. Okay, and for those of you that are wondering, this kind of looks like a Punnett square. On your science GED, you'll probably see a Punnett square, and it talks about dominant genes and recessive genes. It's basically what this is right here. So you got a little bit of science today. All right, So again, this is nothing more than multiplication. So what I am going to do, I'm going to multiply x times x, and I'm going to put my answer here, which is x squared. Then I'm going to say x times 5, which gives me my 5x. Okay, so my two top boxes are filled. So that means my bottom boxes have to be filled. So when I do that, I'm going to say -7 times x. And that's going to give me -7x. So that number goes here. And then I have -7 times 5, which gives me a positive, -35, excuse me. All right. So again, all of my boxes are covered now. So now what I can do is I can combine my like terms. Again, your like terms are more than likely going to be in the middle. Okay, so in this case, 5x and -7x are my like terms. And when I say -7 plus 5, this gives me my -2x here. So again, my final answer is x squared minus 2x minus 35. Okay? So how are y'all feeling? Y'all still with me? Or y'all just don't mute taking notes?
Yes.
Oh, okay. I just want to make sure. You know, technology is very funny. So, and I don't want to assume anything. All right. All right. So now we have one more method to
Something.
Ma'am.
Do you still have the notes on the playback?
Yes.
Okay.
I do. So I'm going to upload this video so that way you can watch all 3 of them.
And copy the notes.
Yes, ma'am. Absolutely. And copy the notes. Exactly. All right. So I have one more method that I want to show you all. And by the time I finish this method, it'll be time for us to go and take a nap. Well, I'm gonna go and take a nap. I've been up since about 7 this morning. I'm tired. But anywho, so let me know when it is okay for me to go to the last slide. And remember, this will be on a part of the playback. So any notes that you may have missed during this session, I again encourage you to watch the playbacks once I upload the video. Hopefully this video will be loaded by 12:30 because the processing takes a good minute for it to, get everything together. Okay. So again, anybody that's watching the playbacks, I encourage you to watch them, take your notes, do everything at your own pace when it comes to the videos. Okay. All right. So I'm going to go to the last slide. Is that okay? Okay.
That's okay.
Okay. Miss Philomena, is it okay? Okay, I guess it's okay. All right. Now, last but not least, we have the distributive property. Okay, so again, the distributive property, it means to give, but we're going to have to break down this first binomial. So what I've already done, is this. I have taken this first binomial, which is x plus 5, and I have broken it down so that each one of the monomials can be multiplied by the second binomial. Okay, so it's, in essence, I'm doing the distributive property twice. Okay, so what I have is I have x times x minus 7 plus 5 times x minus 7. Okay, so again, I broke down these two binomials. So my x from the first binomial is here, and my 5 from the first binomial is here. And I'm multiplying each one of those monomials or one terms by the second binomial. Okay. So again, this is nothing more than distributive property. I'm just doing it twice. So when I do this, I have x times x, which gives me x squared. X times -7 is -7x. Then I'm going to come over here and I'm going to say 5 times x gives me 5x. And then I have 5 times -7 gives me a -35. Okay? So again, my like terms are in the middle. I have them underlined here. So when I do this, my final answer, yet again, is going to be x squared minus 2x minus 35. So I will say this. I know that it may have been a lot to digest. I get it. I totally understand it. But again, I just want to encourage you all, please watch the playbacks. It's very important because I want to make sure that you all are confident in doing this type of work and also understanding how the concepts work and how we apply them, if that makes any sense. Okay. So again, as I always say, there are many different ways to get to downtown Atlanta. I just showed you 3 routes. I don't care how you get there, just get there. Okay. Again, you have to pick the method that is comfortable for you. Some people like the long way, doing the FOIL, and that's totally fine. A lot of people like the box method because it's shorter and it's actually cleaner.
Excuse me, Miss Hampton.
Yes, ma'am.
In the distributive property method, where is that is the question, the question, where is the x? It is not written there. How do you get the x, or do you just assume?
What x?
The x to multiply, because you just wrote out parentheses x plus 5, then parentheses x -7. So the breaking down, I have x before the parentheses. So where did you get the x when it is not in the first question?
It's right here, Miss Philomena. You see where I have it boxed?
Mm-hmm. But it's
So
in the parentheses. You have to move it out.
Yes. So I will rewrite it over here.
Okay.
Uh-oh.
Hello?
I'm here. I'm just concentrating. So Miss Philomena, do you see what I did?
Mm-hmm.
Okay. So does that answer your question?
I'm still not clear. If the first number is the question, so how did you get the x? Or do you just bring out the x to start multiplying it in the parentheses? It's not quite.
Yeah, you mean the x here?
Mm-hmm. Yes. It's not in the first one there as a question.
Okay.
As a question.
Okay. So do you notice that all I did was this x -7, I just rewrote it. Okay. So what I did was I broke down this first binomial. So now I have a monomial here being multiplied by the second binomial, which is x -7.
Okay.
Okay. And then I did the same thing with the 5. So I broke down the first binomial and made it into monomial. So I went from 2 to 1.
Okay.
Okay. And then all I did was I just took each one of those and I multiplied it by the second one, which was x -7.
Okay.
Now remember, again, there are 3 different methods. You have to choose which one works for you. You have to choose which one is easier for you to understand and and what makes you comfortable. Okay.
Okay.
All right. So it
Thank
is.
you.
Yes, ma'am. No problem at all. So remember, ladies and gentlemen, cats and dogs, babies, whoever is watching this playback, you have three different methods on how to multiply binomials. Remember, you have, and I will go back and to review very quickly. You have the FOIL method, which is the most common method. This is the method that I learned when I was learning these things. It was the only method until later on when I was introduced to the box method. Now, as you can see, very quickly. This is just a breakdown. You do not have to necessarily do all of these steps in this way. I just like to break it down in detail so that way you would know what to multiply. Okay? So you don't have to necessarily write it out in that way, but it is important for you to know which terms to multiply, because if you multiply the wrong terms and if you go out of order with multiplying them, then you will get a totally different answer. Trust me, I know, I done did it too many times. Okay. So if you notice with the box method, it's cleaner. Everything is nice and organized, and I still came up with the same answer. No biggie, no problem. All right. And then my third way, which is using the distributive property, that's my alarm. The third way, which was using my distributive property, I just simply broke down the first binomial into, if I can find my cursor, okay, into a monomial. So I have x times x minus 7 plus 5 times x minus 7. And when I do all of that, this came out to be my final answer. Okay. So I am going to say this. I left some practice problems on the Tuesday playback, and it'll be here. So basically, I used the same slide presentation for all of this week. Okay, so I don't want you to be like, oh, this looks. No, I use the same one. Okay, so what I want you all to do, and this is your assignment, and I will still be more than happy to email you a worksheet. But as far as your assignment, it is going to be on here. Okay. So the first four problems, it says solve the following using the distributive property. Okay. So please make sure that you go back and look at your notes and you work on those. Okay. Now, 5 through 10 says solve the binomials using the FOIL, box, or distributive property method. I don't care what method you use, just get the same answer as me. That's what I care about. Okay. And again, if you want to try all three and see which one fits for you, by all means, go for it. I just, again, want to make sure that everybody is confident in doing these problems and understanding how it works. That's what's important to me. I need to know that you know what you're doing. All right. All right.
Definitely gonna need a nap after this.
Y'all, but I know that's why I'm gonna go and take one.
I'm talking about me too, man.
I mean, I'm trying to tell you, and then I think it's raining out there too. The weather is not helping the situation at all.
Yeah,
It's
man.
really not. Again, I know that this may be a lot to digest. That is why I strongly, and I cannot stress this enough, I strongly encourage you all. Once these videos are posted, please go back and look at them, please, because a lot of times it may be something that you may have missed. It may be something that, oh, excuse me, that you didn't catch the first time, and you can watch these videos at your own pace. So I strongly encourage you to watch all of these videos from this week as it relates to like terms and binomials and all these other nomials and all this other good stuff. Okay. So how do we feel about today's session?
Good.
Okay.
Good, good.
Okay. I don't know why my nose, I don't want y'all to think I'm like digging for gold, but my nose is itching and I don't know why. But
Now,
anyway,
are you emailing us this worksheet too? Is that
to be honest, I want you all to do these problems on here.
Okay.
Yeah, I want you to work on these particular problems on here, and that way we can go over these together because it's already on, you know, on the Mimeo board.
I see.
But the other sheet, the combining like terms, I will be
Yes.
more than happy to email that for you.
Okay, thank you.
okay?
All right, so I'm going to stop this screen share and get back on this thing. Again, thank you all so much for rocking with me this week. I mean, I really, truly, emphatically appreciate y'all. I really do. That's real. So if there are no more questions, if you do have any questions, please feel free to reach out to me. That includes you, Miss Philomena, you, Mr. McFadden, anybody that's watching this playback, leave it in the comment section, and I'll be more than happy to answer the questions for you. But I'll go ahead and send you all those worksheets right now. And with all that being said, Miss Hampton loves you. There's absolutely nothing you can do about it. Be safe, be careful, stay home. Don't go nowhere. Okay, stay home. Don't go nowhere because I need y'all. I need y'all here. Okay. So y'all have a good weekend, and I will see y'all on Monday.
All right. Thank you, Ms. Hampton.
No problem. Bye.
Thank you, Miss Hampton.
You're very welcome, Miss Philomena.
You know today is Thursday.
Yes. I know today Thursday.
You said you'll see us Monday.
Right.
Yeah.
I want you to think about that, Mr. McFadden. I need you to think about what I said. Think about it. See, Miss Philomena called it. I need you to think about why I said it. Because today's Thursday. I'm going to see you Monday.
So we're not having class tomorrow.
Mr. McFadden, have I ever taught a class on Friday, sir?
I don't know. I never attended a class on Friday.
Well, that should answer your question then, see?
I didn't know that. I didn't know
Oh,
that.
no. I follow the same schedule that I had prior to Auntie Rona and Uncle Virus coming in here acting a fool.
Oh, okay. See, I didn't know that.
Oh no, that's okay. A lot of people don't know, but that's all right.
I ain't know that.
So it's all good.
Okay, so this ain't. So we gotta have this for Monday, correct?
Yes.
All
So
right.
you got all weekend to do it. See, look at God.
Yeah, I know.
I want to do it. You do it if you let him. But yes, but like I said, y'all, again, thank y'all so very much. Miss Hampton really appreciate y'all, and I'm really finna go and take a nap for real. So if you got any questions, y'all know how to find me. I ain't going nowhere.
All right. Thank you.
All right. Y'all have a good one.
Bye.
Bye.